The last feature I want to show you is the export to FEA option. To do this, we need to first go into the winding options, select Save Laminate Data, choose a name for the laminate data file. This example will use example vessel layer 1, and simply click Start Winding. This will create a laminate data file that then you can then use to turn into an FEA data. You do this by using the File menu, Create FEA Data option. Simply choose the laminate's data, and you can use any number of files with any number of winding angles. I've created 3 layers for this example, layer 1, 2, and 3, that all represent different winding angles on the same mandrel. You can stack these layers in any order you like, which will then be accurately represented in your FEA model. Choose the format. For your FEA software, there are several options there: Nastran, Abacus, Lucis, CosmosWorks, ANSYS. I'm going to use Nastran. Choose a file name. I'm going to call this one example pressure vessel.dat. So the FEA data has been successfully created. So now I'm going to switch from CADWIND to Strand 7, which is my FEA software, to show you the FEA file that we've created. So now we have the FEA software loaded on the screen. As mentioned, this is Strand 7, my software, but it could be any FEA software almost. So I'm simply going to import the geometry and the laminate that we've just created in CADWIND. You can see we have a 3-dimensional pressure vessel laminate already on the screen. It's almost ready to analyze. We just need to really apply loads and restraints and some material properties, which I will apply some loads quickly. So we'll select all the elements and apply a face pressure load of 20 MPa or 200 bar. You can see the brown arrows here representing the pressure load that's now been applied. I'll turn them off for clarity. We'll apply some restraints to some of the nodes. Just sufficient restraints to stop the model from moving globally, and that's all. And we'll just need one at the other end. So now we just need to apply some material properties, modulus and so on. You notice that there's only one ply. By default it has a modulus of 130,000 MPa. It's a little bit high for standard modulus carbon, depending on your volume fraction of course. So I'll just make an adjustment to that. The thickness, we don't need to apply a thickness. CADWIND's already done that at the laminate level. Now we should be ready to solve. Now that our FEA analysis has been solved, we can load the results. And let's just plot, for argument's sake, the stresses in the 1-1 direction. We'll increase the displacement so that we can see it. So there we have it. In a matter of minutes, we've managed to create an FE analysis for the complete pressure vessel with 3 layers in this case, but as many layers as you'd like, with as many different winding angles as you like. It was quite easy thanks to the CADWIND export to FEA option.